Hello, my name is Trina Myers, and today I'd like to introduce you to an overview of the Tropical Data Hub, or TDH, as a virtual research environment to enable knowledge, science and innovation in the tropic regions. But first of all, why bother? Why bother about the tropics specifically? Why develop a virtual research environment that is purely focused in the tropic regions?
Aristotle first defined the area of the Earth closest to the equator as the torrid zone. We also know it as the tropic zone. Aristotle presumed that this area was too hot for human habitation because the sun's rays targeted this region from directly above. He also proposed a temperate zone, which is the band directly above and below the torrid zone, and also a frigid zone near the Arctic circles. Now, he deemed the temperate zone as the only region with a livable climate. So in thinking of the tropics, it's quite typical to think of heat and humidity with abundant rainfall, lush plants and trees, and varied animal life. Now, although rainforests might be the more typical presumption for the tropic zone, many deserts and mountains also fall within the latitudes of the tropic zone. Even snow-capped mountains are possible within this zone. For example, the Andes Mountains in Chile and Argentina fall within the tropical zone, but contain snow and alpine tundra. Large portions of Australia and Africa also fall within the tropic zone. But both of these continents have large areas of desert and savanna with extremely dry year-round conditions. Now, the tropical world is an important but sometimes unrecognised component of the world at large. 40% of the world's population live in the tropic zone, and it's projected to be 60% by 2060. 38% of the world's landmass is in the tropic zone. Biodiversity is not distributed evenly on Earth. A high proportion of the world's biodiversity is located in the tropics, including up to 80% of animal and plant species and 92% of the world's coral reef ecosystems. Now, population growth and urbanisation have led to biodiversity loss on a massive scale in many tropical countries, a process that's exacerbated by climate change. Now, biodiversity is simply one challenge within the tropical zone. High population density and growth are similarly linked to poor health outcomes and to the emergence of new infectious diseases. Also, living in the tropics and making decisions to do with day-to-day routine activities is influenced heavily by the tropical environment. For example, how to best teach our children, where to best locate hospitals and schools, what crops to plant. The commercial evolution of products and services is heavily influenced by the tropical environment. And all decisions require timely information and knowledge. However, there are limitations for informed decision-making for community and infrastructure development, for informed decisions on land management, conservation planning, also climate change mitigation and adaptation planning. And these limitations are due to a lack of the correct data, due to a lack of publication of the data's actual existence, also due to a lack of expertise or knowledge, and even a lack in research areas. Also, how to keep up with the current exponential growth in data when that is really posing major problems in data management and data analysis. So how to manage the data effectively to ensure a linear growth in information and knowledge that's in line with the growth in raw data. So the Tropical Data Hub. The Tropical Data Hub, or the TDH, is a platform to serve data sets related to tropical research and innovation from a single virtual location that will enable researchers, managers and decision makers to collaborate around the data. The TDH is being developed as a knowledge representation platform, so researchers can combine disjoint or unrelated data in a single knowledge system to pose questions of that data. Now, the internally and externally stored data will be published via the TDH in a form that is conducive to the Linked Data Initiative. And the Linked Data movement defines the processes and best practices for publishing and connecting structured and semi-structured data on the web. The challenges of population growth, urbanisation, climate change and biodiversity loss in the tropics can only be addressed successfully through a cross-disciplinary approach. So the philosophy of the TDH is to span traditional vertical research disciplines and enable horizontal research to link across domains. Specifically, vertical research is the traditional discipline and data-specific research paradigms that are conceptual silos of concentrated research efforts. In contrast, horizontal research spans a cross-connect through disciplines, through research methods, data resources, and even experimental techniques to enable synthesis of a diverse range of disciplines and data. So the TDH is a virtual research environment platform for distributed data sharing and processing. Now, a VRE, or Virtual Research Environment, is an open data collaborative model that allows users to integrate and analyse data and information from a variety of sources. Now, the hub, or the TDH, is to be more or less a one-stop shop for researchers and managers and their data and information. So in essence, a single entry point to hosted and remotely stored tropical data. And the VRE architecture facilitates the collection, the discovery and the curation of tropical data, and it can interface to major national and international repositories. And the exemplar derived data products and tools included, and some are still being in development, are for data discovery, data mining, assessment, curation and publication of the data, data processing and management, and tools for visualisation and collaboration. And the data products will facilitate tropical environment research and modelling, as well as knowledge transfers between researchers, managers, policymakers and the general public. The TDH supports data-intensive research on the effects of climate change on tropical environments, in particular the discovery of flora and fauna refugia and biodiversity hotspots that can be used as locations of last resort for species under periods of intense climate anomalies, for example extended drought or heat waves. Climate change threatens the world's major centres of biodiversity, jeopardising many of the collective conservation and development efforts and investments to date. Observed changes and the amount of climate change that society and ecosystems are already committed to indicate that we are already at a rapidly growing adaptation deficit. However, conservation strategies have largely been developed under an assumption of a stationary climate. Now, these strategies may fail with changing climates, especially when in tandem with the existing human pressures. So reducing the vulnerability of biodiversity, including agricultural biodiversity, to climate change requires an understanding of the projected magnitude of change and the potential impacts. So an exemplar visualisation tool developed within the TDH is the Wallace Initiative Climate Impact Visualisation System for visualisation and assessment of significant land use and species distribution data. Now, this system is the product of a major collaboration between the Tyndall Centre for Climate Change Research, the World Wildlife Foundation and James Cook University. The Wallace Initiative is a global effort to rapidly assess the potential impacts of climate change on global biodiversity. It brings together experts on climate change and bioclimatic modelling with global data sets on biodiversity and high-performance computing facilities to model the potential impacts of climate change on approximately 50,000 terrestrial plant and animal species. To date, 100,000 hours of computing time have gone into mapping areas where species are and where models project that they're still going to be in 50 years' time for a range of climate change scenarios. These models are then used to calculate projected changes in percent species richness, looking at areas likely to be refugia under various degrees of temperature change and areas likely to undergo the greatest loss. Now, this information can provide guidance to the World Wildlife Foundation and its partners on how they may need to adapt to climate change to avoid biodiversity loss. Just to have a quick look at the site. Now, we know climate is going to change in the future, and we know, for example, that the current temperature across the globe, as you see here, ranges from negative 27.8 all the way up to 30.4 degrees, and that's in these hottest desert areas. But if we continue as we are today with greenhouse gas emissions at the current rate, by 2080 you can expect huge changes in temperature. So if we choose a single global climate model here, and given that we do continue as we're going, the spatial pattern of temperature is not going to change too much, but the range in temperatures that we're seeing is global warming at a rate of 5 degrees increase by 2080. Now, this can be avoided by simply reducing our greenhouse gas emissions earlier rather than later, and we can see quite a decrease in the impact of temperatures. So here, if we look at reducing our greenhouse gas emissions and capping them at 2030 of mean annual temperature, the range that we'll see is now only on mean temperature is now only 24 degrees up to 32 degrees, so only a 2 to 3 degree increase in temperature. Plus, the researchers can download these data sets directly from the site. But where this site really becomes really valuable is for managers and policymakers if they want to see impact of species or groups of species. Now, for example, look for the mammals across the globe and look for mammal richness. What you see here is biodiversity hotspots in these areas highlighted in green. If we continue business as usual, there are decreases. Vast decreases in species richness and areas of richness, which is what you're seeing here. What was previously all yellow and yellow to green, which is high species richness, has decreased dramatically. So what you're also seeing is that overall all species richness has also decreased from 218 down to 204. But we can now implement the avoid scenario and look at the differences if we reduce our greenhouse gas emissions earlier. Now, as you can see, there is a much larger area which has less reduced species richness here through Central America and through Europe. And notably, there are much less areas where we are seeing reductions to zero. The concept of open data closes the gap across disciplinary challenges and allows for a better informed management, planning and policy in tropic regions and a wider scope for collaborative research opportunities. Now, notably, the TDH portal's key functionality is the amalgamation of disparate data and unrelated data exposed for the purpose of harvesting metadata and facilities to search across all data sources, both vertical and horizontal. And interested parties such as Australian state and Commonwealth government and international and national university research programs and/or management groups will then benefit from the synthesis of linked cross-discipline tropical data, information and knowledge that's available via the TDH. Thank you for listening.